Our next problem asks us to find out the angle of intersection between the parabolas y square is equal to 4ax and x square is equal to 4by. Now one important thing to note is that the angle of intersection between any two curves is equal to the angle between the tangents made to the two curves at their points of intersection. Hence we try to find out the point of intersection of y square is equal to 4ax and x square is equal to 4by. On solving these two curves, we get the point of intersection as one is the 0, 0 and other will be equal to 4 into a power 1 by 3, b power 2 by 3, comma 4 into a power 2 by 3, b power 1 by 3. We can very easily square this equation, put the value of x square as 4by to get the values of y as 0 and this, and similarly on putting the value of y over here, we get x as 0 and this. Now very clearly and very obviously, at x is equal to 0, 0, one parabola is like this, the other will be like this. So at 0, 0, the angle of intersection of the two tangents will be equal to pi by 2 because x-axis and y-axis will be the two tangents. So at 0, 0, the angle of intersection will be pi by 2. Now at the other point we need to find the angle of intersection of the two parabolas. So we need to find the angle of intersection if the two tangents are made to the parabolas at the point 4a power 1 by 3 b power 2 by 3 comma 4a power 2 by 3 b power 1 by 3. For the first parabola y square is equal to 4ax, we know that the slope of tangent is equal to 1 by t, which is equal to 2a upon y1, where y1 is the y coordinate of the point at which the tangent is made. Here the tangent is made at this point, hence putting the y coordinate as 4a power 2 by 3 b power 1 by 3, we get the slope m as, this becomes half, this becomes a by p whole power 1 by 3 and half. This is the slope of the first tangent or the tangent to the first parabola. Now we need to find out the slope of the tangent to the second parabola. This is x square is equal to 4by. The slope for tangent for this parabola is equal to x1 upon 2b, which can very easily find out by differentiating this equation. This becomes 2x is equal to 4b times dy by dx, and we know that dy by dx represents the slope of tangent to any curve, and hence the slope m2 becomes, if the slope is made at point x1, so this becomes x1 upon 2b. And we know the point of intersection, it is given to be, the x coordinate is given to be 4a power 1 by 3 b power 2 by 3, hence putting x as this, we get 4a power 1 by 3 b power 2 by 3 upon 2b. This gives slope m2 as 2 a upon b power 1 by 3. So we just need to find out the angle by tan theta is equal to m1 minus m2 upon 1 plus m2, m1 m2, which is the formula for the tan of the angle between any two lines. Here we need to find the slope, here we need to find the angle between the two tangents at the two parabolas, and hence putting the value of m1 and m2 in this formula, we'll get the value of tan theta as 3a power 1 by 3 b power 1 by 3 upon 2 times a power 2 by 3 plus b power 2 by 3. Hence theta will be equal to tan inverse of this thing. Hence in this question we learned a new concept, that is the angle between any two curves is equal to the angle between the two tangents meet at their point of intersection, and hence the two angles between these two curves are first the pi by 2 and second is tan inverse of 3 into a power 1 by 3 b power 1 by 3 upon 2 times a power 2 by 3 plus b power 2 by 3, which is our final answer.